In this video, we'll start with a bit of an intro to sensing distance, what we're actually doing, why we're doing it. And so when we're talking about sensing distance, we're talking about effectively the concept of range finding. Now, sometimes we do this in parallel where we range find a whole lot of things together, and sometimes we just are interested in a single point and measuring the distance from ourselves to that single point. Normally we do it from the point that we're at to a distant point that we can actually physically see or sense somehow. And we normally try and do it without moving from the point we're at to that other point. So we're doing it remotely. It's a form of remote sensing that we're trying to perform. Now that's what we talk about when we talk about range finding. Odometry is another way we can sense distance. And here we're basically looking at a series of movements, whether it be the odometry on your car that you can work out how many kilometers you've moved by how much the wheels have turned, or the odometry in a robot or a trundle wheel, or lots of other mechanisms around moving parts, so we can measure odometry based on how it's moved or how long it's slidden along a linear rail. Now let's talk about briefly some applications for range finding, and there's plenty of them. Everything from using them in robots, which is one of the classic areas that I use range finding in for robot navigation and obstacle avoidance and those sort of things. The sensors in our cars to do self-parking and obstacle avoidance and those sort of things. Doing surveying applications where we're trying to understand and survey an area, maybe for a new road or shopping center or whatever it may be. Another part that's closely related to that is map making, whether it be topographic maps, whether it be bathymetric maps when we're looking underwater and we're trying to work out what's actually below the surface of the water. All of those things are things that we use sensors for with a rangefinder style application for it. We use them for condition assessment when we're looking at trying to measure and assess bridges and gaps that might be opening up and things like that. We use it for sports and things as well. For example, when we're playing golf, we might use a rangefinder to work out how far the pin is away from where we're currently playing or looking, so we know what club to choose. Snipers in the military and artillery use them as well to work out how far they need to shoot and how far they need to compensate for wind effects and gravity effects and things like that. And we use them for safety as well. And for example, a lot of factories will have rangefinders, LiDAR-based ones on the wall that if someone walks into a particular area, all the machinery might stop or slow down to create a safe zone for that person to enter into. So all sorts of different applications and lots of engineering style applications as well around why we use rangefinders. Now we've got a few different modalities or ways that we can actually perform that range-finding operation. And the first one's a passive. Basically, there's a few different forms of this. One is if we see a distant object of a known size, we can infer from that size and the size that we perceive it, how far away that object is from us at any point in time. And that's because as the object gets further and further away, it gets smaller and smaller. Not physically, but we perceive it to be smaller and smaller. And when we've got a camera or something like that, it takes up less pixels on our camera. And so we can compute the distance or approximate the distance based on that. Another way we can do this passive style range finding is look from two different directions. And that's the classic case of stereo vision, which we have with our eyes. We've got two eyes that have a slightly different view of things. And based on the correspondence of pixels or parts of an image between those two eyes, we can infer depth or a distance as well. Then we have lots of forms of active range finding, where we bounce a signal like a laser or a light or a sound wave off an object and record how long it takes to get back or use phase change. There's a few different ways we can do it. They're the active forms of range finding, where we're actually bouncing something back. So let's go to one of those passive ones first, the stadiametric range finding. And basically in this range finding, this is where I talked previously about those rangefinders used to measure how far the tee is if you're playing golf, or that military snipers would use as well. Now this is a passive form of range finding. And basically we're using it to find distance to objects of a known size. Or we can also use it to find the size of objects at a known distance. So we can use it either way in reverse. One of the advantages of this sort of approach, particularly for those military applications, is it's very hard to detect because you're not beaming out light or sound or anything like that. So there's nothing for the enemy or the person that you're trying to range find to detect. Here's an example of what a military sniper might see through their scope. And you notice that there's a mark there for 1.7 or 1,7. And what it's saying is that range finding part is calibrated for a person of height 1.7 meters, which is a fairly average height for male. So basically, here's a breakdown of how it would look. If a person is 400 meters away, their head would line up with the 4 mark at that 1.7, assuming they're about 1.7 high. And so if they were 200 meters away, significantly closer, well, they'll appear bigger on the scope. If they were 800 meters away, they'd appear a whole lot smaller because they're a whole lot further away. And so it's a really simple way of doing range finding based on, we know roughly how tall someone is, we can estimate how far away they are based on that height. Finally, one really simple rangefinder that we use, which is essentially a bump sensor, a little micro switch that's used for very close ranges. And these are really only used for saying, well, something is touching or it's not touching. Now, one place that we use these a fair bit is in machinery for end stops and things like that. So for example, here's a picture of my 3D printer. I've got an Ultimaker 3 here. And if you look here, it's actually got 2 of these. It's actually got a third one in a different area completely. But as it starts up, it moves and clicks in with each of those rangefinder positions to say, oh, okay, we've got the X position, we've got the Y position, and it's homed into the home position. So once again, very simple form of range finding, and this form of range finding is touch-based, it's tactile, really only useful for those short range applications. But it gives us a really cost-effective way of detecting, yes, we've touched something. And some robots, for example, the Roomba robots, use something similar to this to detect if they've run into a wall, for example, and they can back away from the wall.